All right, so when we factor this, to get the x squared, we would have had to have an x multiplied by an x. And then the two numbers that would have multiplied to be 8 add up to be 6. We hopefully got 4 and 2. Okay. Then I ask you, what are your x-intercepts? The way we found our x-intercepts is we took this factored form. So just underneath this, write x plus 4 times x plus 2 again. And if you remember, whenever we cross the x-axis, our y-coordinate is always a 0. So we let our y be a 0. That's what this notation stands for. That's what f of x means. It's your y. So just let that be a 0. So come on. So make the left-hand side into a 0. This was then where we would just look at each factor. So if I factor right here, we would ask ourselves what x value makes that 0. And that would have to be a negative 4. So that's one of our answers. That's one of our x-intercepts. Go to the other factor, this x plus a 2. If we were to set that equal to 0 and solve it, try to figure out what would make that a 0, that should be negative 2. So those are our x-intercepts. Notice how I want you to graph it. These are two nice pieces of information to have. So we can now go to our graph, and at the x value of a negative 2 and the x value of a negative 4 on our x-axis, we know we have to cross at those values. So we can plot those 2 points. Okay. So that's what we did in the past. Our x-intercepts are a negative 4, negative 2. What we have also done in the past is what I'm going to have you do over here. So now let's take this guy over here. So I'm going to rewrite it. And we want to put that into vertex form. So vertex form is the whole making a perfect square. So we did this a little bit yesterday. We want to make a perfect square out of the first two, the x squared plus the 6x. If we drew out those little rectangles, a little area model, we would have had 3x in one, because if I have 6 x's total, I would have put 3 x's in one corner, I would have put 3 more x's in the other, and you would have done 3 times 3. So to make that a perfect square, that's the 9. And since we added 9 inside, we would want to subtract 9 on the outside. So this written in vertex form, we would have x plus 3 quantity squared. And then the 8 minus a 9 is a negative 1. So that's our vertex form. From there, we now know our vertex is a negative 3, negative 1. We can then plot that point on our graph. So if we go back to the graph, here's negative 3, negative 1. We can now draw a pretty reasonable sketch of this. Looks like this. We don't have to go through our table and get all those values. Line of symmetry. We all knew that pretty well. It has to be the x coordinate. So x equals a negative 3. And I won't worry too much about this right now. All right, what I am going to do though, take this equation and where it says observations, we're going to cross this out for right now. I want you to solve that vertex form equation that we just came up with. So now take that vertex form, just like we did before. So let me do this. Yes, they are, Alexis. Yep. So here's our vertex form. And just like we did earlier, set that equal to 0. Let your y be a 0. Because it's the same form, this should give us the exact same x-intercepts. This is what we just quizzed on that we just went over, our quiz. quiz from Monday. So if I now tell you, let's get this guy isolated, the squared term, we would want to add 1 to both sides. These would cancel, and then you get x plus 3 quantity squared equals a positive 1. This is when we take our square root to get rid of that power, but then recall, you should get a positive and a negative solution to that square root of 1. So we get just a regular old x plus 3 equals a positive and a negative 1. Subtract 3 from both sides, and these will cancel. And then understand how we set these two different equations up. I have a positive and a negative 1 being decreased by 3. So one answer should be if I treat the 1 as positive. So let's do a positive 1 plus 3. I'm sorry, minus the 3. That gives me the negative 2 that we got earlier. The other answer then is if I treat my 1 as a negative 1. So now the second equation, I'm going to do negative 1 minus a 3. And notice how we get the negative 4. Are those the exact same answers that we got earlier? Yeah, just a different way of going through it, either factoring it or by completing the square and then using the square roots in order to get that answer a little bit differently. Okay. And then the last thing, let's use the quadratic formula to do this. So first, quadratic formula. This was the little quiz yesterday, just to make sure we had this down. You had your notes anyway, you could just look at them. That's our quadratic formula. Off to the side, we always want to identify what's our A, B, and our C for the formula. So do that, identify what A, B, and C are. Let me pull this up if you don't have it in front of you. So here's the equation here. Oops, wrong thing. Most of us got this right yesterday, so same thing. A has to be the number in front of the squared term. So in this case, it's a 1. The B is the number in front of the x to the first term, so that's 6. And then the C is this constant hanging out at the end. So C is 8. So let me give you a few minutes. This was your homework yesterday. We've been doing bits and pieces of this for the last couple of days. Plug those in, go all the way through the quadratic formula, see what you come up with. All right, and see if we can get through all of this correctly. So I'll give you a couple minutes, see what we get. Then you should know the answers. This is just a third different way to do what we just did a couple other times. So if you do not get the same answers that we just got, the negative 4 and the negative 2, then we know something is wrong. You have to get the exact same answers that we just got. We did it by factoring first, so that's what we have up here. The second way that we did it is by taking our vertex form and doing the quadratic, or doing the square root stuff that we just quizzed on. And notice how we get a -2 and a -4 here as well. So if you don't get -4 and -2 using the quadratic formula, then somewhere we know we messed up. If you can find it, great. If not, then just make sure we're paying attention when I go through it here in a second. And whatever mistake you would have made, we can hopefully get it corrected for the next time you got to do one of these. All right, are we wrapping up in here? Is that enough time? Yeah, okay. So let's plug in. We're gonna go ahead and do x equals, b for me is a 6 right now, and for you. Here's where I have the first b, but what we talked about before is we don't just want b, we want the opposite of whatever b would have been. So since our b is 6, when we plug it in, it better be a -6. Plus or minus, and then we want the b to get squared, so 6 squared, -4, and then our a was a 1, our c was an 8. Divide that by 2, getting multiplied by your a, and your a is a 1. The -6 we can't do anything with, plus or a minus. The 6 squared is a 36. Minus 4 times 1 times 8 should be 32. And then all over 2 times a 1. Underneath the square root still becomes a 4. So hopefully we got that nice number 4 underneath our square root. What's going on there? Uh-oh, it's not a good sign. What is going on? There. Then the square root of 4 we know. So all I'm doing in this next step, the square root of 4 we know is a rational number. Just quiz on all of that. So that should be a 2, regular old 2, and then divided by 2. So the way we're now going to get these two answers that we got down here is we're going to set up 2 different equations. One of them we're going to treat as a plus sign. So I'm going to do a -6, I'm going to do +2, and I'm going to divide that by 2. The way we're going to get the second answer is we're going to treat that plus minus sign now. We're going to use the minus sign. So now I'm going to do a -6. I'm going to minus the 2 divided by 2. So for this one, I get a -4 on top. When I divide that by 2, I'm going to get the -2 that I was supposed to get. On the bottom, when I do a -6 minus 2, that's going to give me a -8 that I'm going to divide by 2. That then gives me the -4 that I'm supposed to come up with. So all these different ways to do these, sometimes one is better than the other, but they can all be used at least most of the time if it factors. All right. So it wrote observations. The biggest thing I want you to understand real quick, if it factors, so notice how this thing would have factored. If it factors, you're going to get nice rational numbers. Okay. And because of that, that means you're going to get a nice perfect square underneath the radical that we're going to be able to get some nice answers to. You don't get the ugly plus or minus radicals everywhere. Okay. If it doesn't factor, then that means you're going to get some irrational numbers, and these get, and that's kind of what the next one is. All right. Did we all come up with that, hopefully? The quadratic formula one? All right. So go to the next one then. And then now, this one, if you try to find numbers that multiply to be 2, there's not a lot of options. The only way to multiply to get a 2 is a 1 and a 2. There's no chance that those are going to add up to be an 8 or a -8. So for this question, when it asks, does this factor, that's a definite no. Okay. What that means now, so let me just go what we just talked about. Since this one was, yes, it factors, that means we were going to get rational numbers for our answers. So when I went to do this quadratic formula down here, nice rational numbers, When we do the square root method, nice rational numbers. This is a no. So what does that mean? This means our solutions are going to be irrational, which kind of means they're going to be ugly. You're going to get the whole radicals, plus or minuses. They're not going to be nice numbers in the end. Okay? So let's go ahead. A little review. Put that into vertex form. So x squared minus an 8x, make that a perfect square. And then whatever you add in there, we're going to have to subtract from the 2. All right, so hopefully what happened, if we set up the little rectangles, I'll do it up here. The negative 8x, you would have put 4 in one corner, 4 in that, and then I had a negative 4 times a negative 4, so 16 would have made that a perfect square. So I add 16 there. That means we've got to subtract 16 on the back end. So our vertex form is x minus a 4 squared. And then 2 minus 16 should be a negative 14. So our vertex form, that's what we're putting on this line. All right, for our vertex, that's easy. It's 4, negative 14. The line of symmetry, which is the same as the axis of symmetry, is what Alexis asked. So yeah, line of symmetry, axis of symmetry, same thing. That should be x equals a 4. And again, I don't plan to do that. All right, so we can now, let's go say we want to graph this. Go to 4, negative 14. Uh-oh. Bad planning by me. Let's just put it down here somewhere. So here's 4, negative 14. All right. From there, we might actually stop. What we're going to do next, so what I'm going to have you do down here, we're going to solve this using the square root method. And then we're going to also solve this using the quadratic formula. Should get the same answers either way. But both of those take more than 3 minutes, probably 2 minutes, which is what we got left. So we may pause right here and then pick up with this tomorrow. All right. So not enough, no homework or anything, nothing that I gave you to work on. Just bring this tomorrow. If you have any questions on the quiz, so if you're not sure why you still missed something on either one of those 2 quizzes, you have 2 minutes to ask. You can stick around. But if you're all good, then you can take off and we'll see you tomorrow. All right, see you guys. Somebody say something? Got it. Stop recording this. Yes, ma'am.